Welcome to part 2 of our discussion of key combining operators in RxJava's Observable class. Combining operators can be used to create an observable from multiple sources or iterations. And here we're going to talk about the reduce, collect into, and collect combining operators. We'll start with the reduce operator. This operator can be used to reduce this observable's values into a single object of the same type as the emitted items. Reduction is performed using a by-function parameter. This parameter is passed the intermediate result of the reduction and the current value that's being evaluated from the observable. Let's take a look at an example here. Let's assume we have an observable of integers in the range 1 to 4. The value for integer that's initially used will always be 0. That's the default value for an integer. Here you can see we take 0 plus the first item in the range, and that, of course, will yield 1. So we get the next intermediate value of the reduction. This process then repeats for each pair of values in the range. So once again, we take our intermediate result 1, take the next value in the range 2, add those together, we get a 3. We then take the intermediate value 3, the next value in the range 3, add those together, and we get 6. And then finally, we take the intermediate value 6, the next value in the range, the final value, in fact, 4. We add those together, we get 10. So that's just a simple example of how reduce can work on an observable. The final result is emitted from the final call as the sole item of a maybe. And a maybe is an RxJava class that has 3 possible results. One is the value, the second is an error, and the third is an empty result. For example, if an observable emits no items at all, then of course the maybe will be empty. And that's a perfectly valid result to have from a maybe. Something else to keep in mind is that the internally accumulated value will be discarded if an error or an exception or a cancellation occurs. Something else to keep in mind is that the upstream must signal on complete before the accumulator can be emitted. And otherwise, you'll have problems if it never calls on complete. Let's take a look at a simple example that we'll talk about later when we get to the case study at the end of this lesson. This example is going to take an array of big fractions and use the fromArray factor method operator to turn it into an observable of big fractions. We'll then go ahead and use the concurrency idiom that's part of the flat map operator to multiply each big fraction in this observable stream by a constant using a pool of threads. And then we'll take the results of all those asynchronous multiplications as they complete, and we'll sum them up by using reduce, passing in the big fraction add method reference. Keep in mind, of course, that sources that are infinite and never complete will therefore never emit anything using the reduce operator. And therefore, an infinite source is very likely to lead to a fatal out-of-memory error, which is naturally a bad thing to have happen. Project Reactor's Flux class has a reduce operator that works essentially the same way that the reduce operator works for RxJava's Observable class. Here you can see the same example we looked at for observable, just using a flux to sum the results of asynchronous multiplications. Interestingly enough, Java Streams has a reduce method that's part of its stream interface. And as you can see here, that can also be used in a very similar way. So we take a list of items with the values 1, 2, 3, 4, 5, 6. We turn it into a stream, and then we use the reduce method in order to add up all the values in the list. Notice in this case, we have to provide an explicit value of 0 as the default. Let's now turn our attention to the collect into operator. This operator can be used to collect items emitted by a finite source observable into a single mutable data structure. The first parameter, which is passed in here, is the mutable data structure used to accumulate or collect the items. For example, you can see a little snippet of code here where we're going to pass in an instance of a new array list that's initialized to work with big fractions. The second parameter that's passed in is a by consumer, and that accepts the accumulator, which is the first parameter, and an emitted item, each one that's emitted in the stream of observables. And then, of course, the accumulator will be modified accordingly. So as you can see in this example, we're going to pass in the add method on list, which will be used to go ahead and add each new element to the array list that we passed as the first parameter. A single is returned that will emit this structure, this mutable data structure, which in this case would be an array list. You can think of collect into as a simplified version of reduce that doesn't need to return the state on each pass. So it's a bit stripped down and streamlined. Here's an example that we'll take a deeper look at when we get into the case study at the end of this lesson. What this is going to do is it's going to take a list of big fractions, convert it into an observable stream using the from iterable factor method, then use the flat map concurrency idiom to do a bunch of multiplications and reductions, and then it'll reduce and get rid of the various fractions that are going to be less than 0 or 0, only allowing things that are greater than 0 to get through. That's what filter does. And finally, we're going to use collectInto to collect the results into an array list that will add all the elements into this list. Project Reactor has a collect operator that works very much the same way that collectInto works in RxJava. Likewise, there's also a collectList operator defined on Flux in Project Reactor that's also very similar, although it's a bit more limited because it only works on lists. You can't parameterize it with other data types as you can with collectInto. All these methods are very similar to the stream collect method that's defined in Java streams. Here's a simple example where we create a list of values of integers from 1 through 6, and then we go ahead and eliminate all the odd number values. So we only allow even numbered values to go through the filter, and then we collect the results into a list. So we have a list of even numbered integers from 1 to 6 in our final result. Finally, we're going to take a look at the collect operator. This operator collects the finite upstream's values into a container. And the parameter that's passed in here is actually the Java stream collector interface, which is used to define supplier, accumulator, and finisher functions. Collect returns a single that emits the container that's been collected into. This operator can also be thought of as a simplified variant of reduce that doesn't need to pass the state on each pass. So essentially, you can see here we have a very similar example to what we had before. We're going to generate a bunch of big fractions up to S max fractions number of them. We're going to do some reductions and multiplications using the flat map concurrency idiom. And then we're going to collect the results into a list. So all the processed big fractions will be collected into a list. And we'll take a look at this example in the case study at the end of this lesson. This collect operator is also very similar to the collectInto operator, just a little bit more broad because you can pass in a collector rather than having to pass in a particular data type. So it's a little bit more generalized. Interestingly enough, Project Reactor has a collect operator that works essentially the same way that the one in RxJava's Observable does, and as well as the fact that there's also a collectList operator that's also very similar, although it's more limited because it only works with lists, whereas collect can work with other data types as well, like sets or maps and so on. And again, all these things are very similar to the collect method that's defined in Java streams. So this particular example is a little different from the one we looked at before because we're going to make a list of integers that have duplicates. Then we're going to go ahead and filter out the odd numbers, and we're going to collect the results into a set. So of course, remember, a set does not have any duplicates. So this just demonstrates how collect is a little bit more powerful than some of the other things we've looked at here, because we can collect into a set instead of just into a list. So this is the end of part 2 of our focus on key combining operators in RxJava's Observable class.